In this video we'll be discussing the eccentric reducer in Digital Pipefitter. It's not your average joint. In fact, it's not a joint. It is a template generator for an eccentric reducer that you can build out of flat stock. Let's start by opening a new eccentric reducer. Under the File menu, New Joint, Rolled Joints, you will find a set of joints that generate primarily flat templates intended to be applied to flat stock and then bent into shape. The eccentric reducer is one of these. With this component, you can connect two pipes of different diameter which are offset from each other. The end openings are parallel to each other in order to attach to the straight cut ends of the two pipes. The parameters required are very similar to the rolling offset joint, except that there are two diameters to specify. Run is the distance between the two parallel ends. Set and roll together specify the offset of the second end opening from the first. Notice that the offset dimension shown is the effective offset given the combination of the set and roll parameters. If set and roll are both 0, then it generates a concentric reducer. I'll now set the roll to 3 to move the offset to the left 3 inches. The template preview includes a set of construction lines to show the direction of the bend around the sheet. If you're using a brake to bend the component at specific points instead of rolling the component, you can specify the number of brakes, and the construction lines will show you where to place each bend. This results in a faceted appearing reducer. Set the brake lines setting back to 0 for a smooth roll. Now let's set the roll to a larger number to exaggerate a property you should know about. It's important to understand that the resulting reducer shape is not a round cone. It is elliptical in shape. This allows the end openings that attach to the pipes to be round. So when rolling the component, roll it so that the ends are round. Don't just roll the sheet round and expect the pipe holes to be round. Also, because of the geometry, the end bevel will not always be the same as the specified wall thickness. Here you see it is much wider in this area. When attaching pipes, locate them so that there is an equal amount of extra bevel on the inside and outside of the pipe at every point around the opening. The joint constructions are a little different from a normal joint. We've been using bevel cut, which generates two cut lines, one for where the bevel intersects the exterior of the reducer, and one for where the bevel intersects the interior of the reducer, when projected perpendicular to the surface of the reducer. Hand bevel generates one cut line, which when cut perpendicular to the surface leaves a little more material, so that when the long end is ground flat, the result is the same as a bevel cut, but easier to fabricate. Midpoint is an odd setting. It also gives a single cut line, which after bending will result in the midpoint of the bevel, all the way around the hole to be in the plane specified. It's a result halfway between bevel cut and hand bevel. Before I finish, I want to show you a reducing rolling offset joint. This is functionally generating the same transition from the same pipe sizes and with the same offset as the eccentric reducer that is also shown here. Here the connecting pipes are mitered to fit the bevel of the reducer, and the reducer section is round instead of oblong.